Good morning, my name is Marie Jones. We are very sorry for the delay this morning. We had some fire evacuation. I will be your facilitator for today's presentation. Throughout the course of the webinar, you may wish to ask a question. This can be done by typing a question in the space provided in the Questions tab. Upon receiving your question, we will respond at the conclusion of the webinar. The webinar will be recorded and made available on the NECA YouTube page for later use and reference. Finally, I would like to thank you for taking part in today's webinar, and on that note, hand you over to today's presenter, Roger Sharp from Stowe Australia, who is also a committee member on the Wiring Rules Committee. Good morning.
Morning. Sorry about the delay. Anyway, moving straight into the exercise. Today we're discussing the Wiring Rules public comment draft that's been recently issued by Standards Australia to attract comment and progress report on the next edition of the Wiring Rules. Some of you may recall we talked about this in 2013, where we surveyed the industry and the exercises there. Do you want me to just change that?
Yeah.
Okay. In that presentation, we talked about the issues as what the Wiring Rules, to say the expectations, which I'll just skip a few things here. We talked about what we wanted as NECA. We talked about new materials and methods being relevant, allowing for more guidance through appendices and figures, less prescriptive in exercise there and considerations of cost. But let's look at what we produced today. We've got a document here of some 540 pages long without an index. It's certainly large. There are marginal bars added to help you guide you through as to where changes are, but you'll see very clearly that's very numerous. The most useful document is a schedule that's attached in 52 pages, which finds the main points and identifies all the other issues there. There's quite a few points in that exercises there, which will give you some guidance. At the end of the day, there's also some drafting notes or major concerns where the committee has yet to make up its mind as to the best way forward, and is asking you particularly for feedback in the exercise there. We have, let's see, we've got, let's go back again. The process involves in giving comment, and you're all welcome to do so individually as well as through NECA or copy NECA in, is to get a hold of the draft, which is available through the link that NECA set up, New South Wales has set up, and also from the Standards website, which is listed in the documents. You'll get that as well. If you're submitting comment, it must go through the Standards website, and you're required to do so, which makes a rather formal process. You'll see it's time consuming. Think about it before you open it up, but comments are welcome. There are several hundred comments already in for the committee's discussion. These comments should be in by the 20th of June, which is not much time as the exercise is there. So today, though, we're just looking at major items, and I'm going to highlight some of those things that are in the schedule and just draw your attention to them. I won't be putting a lot of text up, let's hope. Exercise there. Firstly, Section 1. It's a document which some areas of the country don't seem to use as much as others, but I believe it's a very important fundamental there. And again, we're trying to keep it's our link to international processes and keeps us aligned, albeit Australianised. The process in Part 1, this Part 1 solution, some of the regulatory entities now consider that rather dangerous to have such alternative solutions, but NECA's position is we want them, and we'll continue to argue to make sure that they're not encumbering. Section 2 is on protection. Here again, one of the objectives was to try to explain what's in technical words, and we've certainly now extended it to some 9 drawings showing over current options in the exercise there. There's pictures such as these throughout the standard, which we refer to as more text added, and all the exercise there. Hopefully once you've come to grips with it, you'll see that it does work reasonably well. It's not a technical change, but it's just a better way of presenting it. 255 is on arc fault protection. This is the internal arc faults, the serious concerns these days as raised by protection methods and things that to do. There's a comment there where it appears to be extended from switchboards from 800, which were considered heavy current, down to 100 amp switchboards, and I'm not sure that the people responsible or the group putting that forward understand the exercise. But we will talk about switchboards a little bit later too. Discrimination is another big thing on larger projects, and certainly that's similar, gone through a similar explanatory process. RCDs are something which should probably all be interested in the exercises there. In residential areas, we've now allowed for basically every circuit in residential applications, formerly domestic but now called residential. 30 milliamp is basically the requirement. It's extended to there, but allowing an exception for 100 milliamp exercises for heating elements to cover us for water heaters and ovens and concerns of those. So it's more comprehensive, as it's a natural build-up over the previous years. In non-residential, it's still 30 milliamps on all socket outlets and lighting subcircuits, 20 amp. It's extended to cooking appliances in a similar way to residential, and there's a similar exception in that exercise there. Probably most important in the non-domestic or non-residential area is a drafting note which has been included in intimating that the committee is looking to have all circuits in non-domestic, non-residential applications up to 32 amp circuits, single phase and three phase and two phase, to all be protected by 30 milliamp RCDs. So that sounds sensible enough for power supplies and lighting circuits in the single phase variety. But when we look at the application to motor circuits and the things of that nature, there's the question is arising as to whether it's viable or not to do so. It's being brought about, as the committee suggested, by a range of service personnel applications on old installations, whereby, because there's a lot of service on air conditioning situations, you need to have it energised to carry out the testing activity, resulting in a couple of accidents and fatalities where the exercise is there. But it does have implications. It does involve trying to fit, if it goes through 4-pole devices onto chassis DBs. It does involve VSDs. It does involve cooking equipment in large commercial kitchens. It does involve a lot of things which we consider, or at least I consider, have potential for nuisance tripping, and we should have a little bit of a think about that. So any comment you make would be appreciated. RCDs in schools, we've now picked up on the New Zealand requirement, and this introduces us to 10 milliamp devices. There are some exceptions. There's a lot of words involved in that, but the basis is fairly simple: socket outlet circuits, 10 milliamps, in addition to the 30 milliamp rules that exist. Alterations and additions for all installations. When you're adding RCDs to existing circuits, the committee, or quite a large portion of the committee, felt that at what point do you, if you're adding a large number of RCDs, why wouldn't you add the lot or revamp the whole switchboard? So there's a comment made there, or an addition there, for 20% of new circuits being added. You should extend RCDs to meet the requirements of the new standard. That can involve, as you'd be aware, in switchboard changes and the like. There's a summary table I'll talk about briefly otherwise there. Arc fault detection devices is a new provision. These are not related to high current switchboards and internal arcing faults and flash suits and things like that, but are a device which detects a high resistance connection, something which can result in electrical fires, arcing faults behind switches, port terminations and the like there. Its origins are in the United States, or from the United States, particularly a Square D, I believe there, and products are available from suppliers such as Schneider, who, funnily enough, share Square D as one of their entities. So these are recommendations, not requirements, and they're done in the same manner as for surge protection. In what we're trying to do is to, if you do need to install them or are considering installing them, these are some recommendations where you should look at, and this is how you may do it. There's Appendix O, contains a fair bit of information there, but in Australia it is not a requirement, it needs to be underlined, but in New Zealand there are some requirements for those applications. We're talking about places which are of some risk, such as museums, historic buildings, where the consequences of fire would be devastating, dormitories, anywhere children may be involved, unprotected by sprinklers and the like. Section 2 switchboards, the main drawing there, figure 2.18, has been modified, and with the intention of increasing distances when a switchboard is found in its normal switch room access position, that is with everything closed. So in that situation, we're asking for a metre around the switchboard on the operable surfaces when everything is closed, and that allows for clear access. At the moment, you can argue for lift-off panels you only need 0.6, and that's not consistent there. But with things open, you still have to apply the rule, 0.6 from the edges of doors and positions and things like that when they're open. So it's not particularly more damaging, it just tidies up some more clearances in larger switch rooms. Another one of those is a clearance where we've allowed for facing switchboards, recognising that only one may be opened at a time or quite easily to open. And in such case, the distances can be measured from the larger switchboard with assuming the other board is closed. Just an old discussion item that's now in a drawing. Thermal insulation. There's been some testing of actual cable testing some years ago now, as it turns out, which validated that TPS cables passing through bulk thermal insulation are generally, of the modern, particularly the V90 type cables, are generally capable of withstanding most of the provisions that are thrown at us for derating. So in air now, in a bulk thermal insulation, up to 150 millimetres is treated as in air touching, so that's not a significant downplay. If it's up to 400 millimetres thick, which covers a lot of the higher R ratings, and partially surrounded, which again still fits under our 20 amp circuit breaker on a 2.5, and greater than 400 completely surrounded, which is the only penalty you need to pay. Thermal insulation has also been extended in a similar manner to RCD protection, so things tie up a bit there. So the areas, all roof spaces, wall spaces and underfloors in domestic installations are to be treated as though they contain thermal insulation. As in all normal new practices, of course, building practices, they would be at any rate. The installation method in ceilings, where we've got large, high temperature areas, parts of the country, the process there is to actually, it is better for the cable rating, if you like, to place the cable on the ceiling and cover it with thermal insulation as opposed to putting the thermal insulation down and laying the cable on top. Both provide an acceptable practices there. Yellow insulation of cables has raised the ire in Victoria, but so particularly sleeving of yellow is not something which they think is acceptable, and trying to make it more process orientated there, but we haven't got through that arguments yet or discussions yet. But look out for yellow. You won't see much of it in the normal process, of course, but in existing installations it's something to be careful of. 3942 on mechanical protection. There used to be a zone of 150 mil around the areas you could run cables without protection. That's now been deleted, and you're subject to the same treatment as less than 50 millimetres, but looking for mechanical protection or RCD. But having said already that RCDs are now much more prevalent or required in domestic, that'll be your solution for most parties. Underground wiring, a bit of a technical issue on sloping grounds where you measure it from. It's fairly clear by the common sense approach, and that's now being documented or drawn up for sloping ground. You will see new materials these days. Become familiar with new conduits, as Australia reduces its amount of conduit production probably to 2053. We're moving towards the international version, 61386, in which case it will still be known to you as very light, very heavy duty, grey to orange in exercise, but you will see additional classifications for the different systems now. And that'll apply to rigid UPVC, corrugated and the likes of conditions like there's a numerical system. We've added an appendix to help see that transfer. 413, equipment weatherproof, what constitutes weatherproof? Returning to an old ruling, and an old rule we used to make that underneath the eave of a space can be considered to be protected by the eave, and therefore the requirement can be reduced to even down to IP23 is acceptable as being weatherproof in that location. Soft wiring and installation couplers. The committee was in, or parts of the committee were in two minds. They thought soft wiring needed to be developed, and because it was being introduced as being performed by unlicensed people and things there, but he was quite readily reminded that is not the case. Soft wiring is licensed work, and the system that's in there of installation couplers, while it's a clumsy term, is still the case in 4.3. So we're reinforcing the exercise, not softening the exercise, reinforcing the aspect that this is licensed work, and the socket outlet at the end of the circuit is part of the installation. Switches near cooktops, gas code, again putting a picture in helps the exercise as it comes across, GPOs and switches, and you'll see a bit of a realignment with the gas code through some of the other documents there. Downlights in 4523 was quite a big issue for us some years ago, and finally the standard for recessed luminaires 60598.2.2 is now being published. It does contain quite a lot of classification. There are many pages in the standard now devoted to pictures and explanation as to what you will see. But for the most part, it's aligned with a New Zealand system, but for the most part from what we've seen in the marketplace, we'll have to wait and see whether it does make an impact. There is a question of low wattage LEDs in domestic type applications. Are they affected by thermal insulation? At this stage it's a case of keep it clear from thermal insulation and follow the manufacturer's directions, but the amount of distances are not as onerous as they were in the past. 418 is gas equipment. That's another one of these codes, highlights there. So certainly in domestic installations where the gas cylinder or the gas regulator or those type of things there's been trying to align with 5601, which is the gas code. So the two documents, 3000 and 5601, make the same statements. Air conditioning in 419, we have seen a bit of work on isolating switches in those areas in the past. And now at there's been a suggestion that the isolating switch requirement should be adjacent to but not on the external compressor units for split systems and things there. That's going to be reviewed because I'm sure that there's quite a few people already commenting from that side of things that that's not practical, and it doesn't add anything to the isolation processes that's there. Something a bit more technical, earthing substations. We're recognising that in larger installations now where we have either private or on-site substations, then we're not strictly speaking in an MEN environment or a multiple earth system environment, but we do have a combined protection and earth neutral applies. We need to be a bit clearer with our terminology in that respect there. We see this will bring in a case where, while earth electrode resistance is nothing at the moment, there will be an earthing electrode or system reference things and resistance values which will become valid in the exercise there. But whilst it becomes still generic, it will fall into place. We'll still call it MEN in a generic type of manner, but we'll hopefully move to PEN and others. Metal building frames. Again, the committee has taken rather a simplification process and requiring all metal frames of buildings, usually domestic construction, but also commercial, non-domestic, to be earthed. And basically that really only means where there is a cable running through that frame or as part of that frame, run the exercise there. In the BCA there's still a condition, and our existing standard there's still a condition for 1 point being sufficient, and I think that they'll still be following that process there. Once again, there is a benefit of, because we are having RCD protection, that having an earth metal frame will be a valid way of offering additional protection and ensuring that works. Outbuildings, somewhat tougher now in the exercise, particularly in townhouse type activities where we've got multiple buildings sharing a common concrete pad or the like, processes there, a lot of multiple installations. These can only be configured as a distribution board system now in the exercise there, where there's a separate main switchboard for the development, for the practice, and each of the outbuildings has its own distribution board. So the MEN is elsewhere, you'll have an earthing conductor, it won't be treated as an outbuilding in that respect. This is for multiple. The single outbuilding rules still apply for singles, where you can create a separate MEN and main switch provisions. There are some additional clauses to look at too, such as the bonding of metal frames and pipes within the building. They'll still be set up individually in each of these outbuildings, but you can share a common concrete bathroom floor type bond as per the rules there. You'll still have what's called main switches in the DBs in the same way we do for most other normal vertically orientated multiple installations. Swimming pools, there's been a rewrite of Amendment 2 which talks about the common bonding connection point, and just to clarify, it's required where the pool structure is, unless the pool structure is non-conductive and absolutely non-conductive, then you'll need this bonding point, and the bonding point will be earth. Tying all that in together with fence structures and the things like that, there's been some modification to try to add some sizing relaxations there. Bathrooms, no significant changes this year round. The heights are still the same, the zones are still the same, the practices of 0.6 and 1.2 are still much the same. We have, however, modified the drawings to allow for overhead spray fixtures, and that applies there. No real difference from a wall fixing, but it does allow for that exercise there. And all openings of showers, whether it's a curtain, a door, a sliding door, or a hinge door, are all regarded as a barrier to define the Zone 1 and Zone 2 type applications. Technically, line-up of hand basins and spa pool sizes with what's in the relevant documents for them, the exercises there. Special installations, Section 7. We've discovered in the processes here that whilst it may be the bigger end of town type of thing, that there's been depending on your regulatory environment, the one in Victoria seems to be quite different than what we're experiencing in New South Wales, and there's been a move in Victoria to strengthen or make more onerous requirements out of safety services based on the fact that you could have what they call a fire management system produced, or a fire engineering report type of arrangement, which could run into and determine or dictate alternative supply arrangements. We're reluctant to take that on in New South Wales. Different regulatory body, different inspection process, of course, but we'll move with the fit provided that the standards match the exercise there. Lifts have now, there is no longer a AS 1735, which was fairly prescriptive about lots of things, and wiring rules aligned. We're now obliged to see what's in the relevant standard EN 81, and we're still waiting for feedback from lift peoples about that exercise. But it's certainly different views and certainly something to be aware of. I'd read that standard, that part of the standard if you're interested, very carefully, and offer any comments that you want to do so, because the impacts could be quite significant in commercial. Generating systems, we're tidying that though there's be a new 3010 for engines or diesels or petrol-driven generator systems. 5033 for PV systems has been revised and will be tied up there. And inverters in 4777, anybody involved with PV systems, solar systems and grid-connected inverters will be quite familiar with those type of documents there. All in all, from a wiring rules perspective though, we're just looking to see how we address this common isolation methods for not necessarily switching the neutral. We don't see that as being a typical requirement for the exercise, and the use of the installation itself to provide the earthing and not having any particular separate arrangements and things there. So from my rules perspective, there'll be a lot of cross-reference to these standards, and hopefully we'll be able to get something tidied up in the drawing picture to make it easier. Verification, there are some new clauses on extra low voltage testing in exercises there, a subset of low voltage testing. But the main areas we've had questions raised in the exercise has been earth fault loop impedance tests, and the common arrangement or question is when don't I have to do so, or where do I have to do so, and the exercise is there. So we've reiterated most of those into questions. Most of them are notes. That's not, you're not required on any RCD protected socket outlet circuit. Quite clearly the RCD provides for all the necessary high impedance requirements. We're not looking for a 1 ohm type of resistance in the exercise there. It's not required on lighting or fixed equipment, whether they're RCD or not. It's only required on socket outlet circuits that are permitted to not have RCDs. And that could be something that, well, certainly if we're going for more RCDs, it's less likely to be a problem there. In large installations, we still have to design to meet clause 5.7 rather than use rule of thumb tables with exercise measures there, and it's about validating by design, not the use of earth fault loop impedance testing is not the issue. Another common question came up with testing devices and testing equipment was RCDs. and the RCD tester and the time function, our tripling and time function, we've made sure we confirm the note that you're not required to do the check operation, and you're not required to use an RCD tester on a time on the road basis. And if you do so, that you'd be aware that it's 300 milliseconds, not 30 milliseconds is the trip time, so don't reject them on that basis. Switchboard assessment. There's a fair amount of interest out there, particularly on a technical sense, of whether an existing switchboard is suitable, fit for purpose, how it remains safe or proper for the applications, given now we're dealing with a lot more WH&S provisions regarding isolation and safe working processes and things in that nature there. So with the standard new IEC-based version, which is only a development of what we used to have for 3439, we're attempting to provide some guidance on assessing a switchboard as to whether it's suitable for continued use based on its understanding its construction, like its Form 3 separation, the temperature-izer bus bars, if we're adding to something, the exercise there, the fault withstand, obviously the selection of switchgear being an assessment type process there. So hopefully, whilst it may be on the technical side of things, end of exercises there, it's something that we can get to see that we can improve the lot or improve the consistency, in not saying some switchboards are okay to use because it's been good for 25 years and that's why they don't become good for use. We've got some new appendices, and a lot of these are new from K right through. So Appendix M is being added to talk about assisted living type premises, particularly where care is there, provide recommendations and measures that could be incorporated into the installation to reduce consequences of unwanted shock situations or loss of supply. Most of it's about trying to ensure that it's a number of circuit things, it's RCD protection being spread conveniently there, that people aren't disaffected, people at risk aren't disaffected by mobility concerns. A lot of those things came out of the New Zealand Christchurch earthquake, so a fair bit of understanding is recognising what they've gone through there for such a long period without supply. Appendix N deals with the conduits I talked about before in 61386 and provides a method of comparison which will put us in good stead between a reference source between looking at an existing 2053 conduit to the new conduits, what the meaning of the additional numbering system is. We're fairly certain the industry will sort out quickly what's the most cost-effective type of conduit systems to use, and so the numbering won't be, so the number of options will not be that significant. Appendix O provides a guidance on how to install why you might consider these arc fault detection devices, AFDDs, and where you should, how you should use them or how they should be intended. It also explains their operation, the processes there to give you an understanding of that. Appendix F is something which we identified as being in our to-do list, and we've made a start at the exercise based on, but it's a lot of ongoing activity and interest, as you can imagine, with electric vehicles. And we're not talking necessarily Tesla type systems here, but we're talking about the more simple standard slow charge, overnight charged domestic electric vehicle thing. So it looks like at this stage of the options, the 20 amp 3-pin flat pin IP rated socket outlet on a dedicated circuit will probably be the most adequate for most intentions as on customer needs at this stage there. Everything comes with a vehicle rather than having to provide everything in the installation. Appendix Q is an attempt, it's fallen out, this is something which has arisen out of the PV installations, concerns with DC and the experiences that people had with rating of switchgear. Not so much cabling systems, but at the end of the day it's where we've adapted AC equipment to DC and the lessons that have been learnt in that exercise is there. There still needs a bit of work to tidy it up because it's just been put together, but it's good for an idea, it's a good process to begin with, and we can process it there. Quick recap then. I think as we discussed in 2013, we talked about the exercise there. It's not a new edition of the rules. It's pretty much keeping in the same line of what we've got there and adding to it in some things. Certainly it was a familiar product. covered the same things from the same clause locations, the same type of things. Some people have taken a view, and the opportunity is rightly so, is to say, well, is it understood, and trying to make things clearer. It's certainly a larger document, and I'm assuming from the 500 odd pages we've got at the moment without an index that the days of having it printed on a B5 type, even spiral bound one, will no longer be valid, and we're probably looking to, if it is hard copy, as well as of course the familiar soft copy stuff, it'll be based on an A4 type construct. Whether it has anything handy with it about searches and the exercise there, they'll all be part of the normal system, so it will be on software process, it'll be easier to find. But it will be there. As far as costs, you can expect it to be pretty high in the exercises, as all these things are. So where do we go from here? Well, after we get your reviews and the exercises there, the next stage is for the committee to meet, which it's meeting quite regularly these days, which is one good benefit of the new structure and the exercise there, and having the states do things. The main committee meetings are much more detailed and specific in the exercises there and frequent. The document will put together and go to a ballot. There is an expectation in standards that it would be published in 2016 still to the end, but that'll be subject to probably early 2017. There's been common practice with a period of grace allowing for those, so its impact won't be in there. But if you have a comment, we'd certainly want you to express your view, get it online, get it to NECA, particularly if you think there's a large swell of opinion on certain things. If you don't agree with the proposal, or you want to see more work done in areas, or have got some ideas of what should be put in areas, please submit them, and please let us know what you're wanting to do with the exercise there. Thanks.
Okay. We have a question. In regards to RCBOs, is it true to say that all outgoing circuits will need to be protected by RCBOs?
Yeah, well, RCDs, RCBOs, RCCDs, they're the residual current component will be is the intention there. The committee feels that learning from the experience since 91 has been a positive process, but my only concern is at this stage we haven't really costed or done any attempt to analyse the consequences of going to every circuit in the exercises there. We've always kind of held back, if you like, on non-residential type applications to some extent because it's such a changing process, and it's also the practicality. We're not looking at small domestic circuits, we're looking at large numbers of circuits, and the ability to protect them is awkward. But keep in mind how to do these things and what the challenge is going to be. But as I said, a 4-pole RCD or RCBO is not going to fit readily onto a standard commercial switchboard chassis. So you're going to look at different ways and means to do that exercise there. Yes, Wendy?
Yeah, okay. One more. Has there been any thought into maximum demand calculations to take into account evolving technologies such as LED lighting? Current maximum demand calculation don't reflect LED load.
Okay. Yeah, look, that's true. One of the things we did set out to do, or tried to do this edition, was to ask somebody to review maximum demand on a more comprehensive basis. But you are free to use LEDs, smaller loads. You can do the exercise there. You're quite entitled to use the actual load of the lighting system rather than to an assessment in the exercise there. But at this stage, there's been no activity to improve the exercise at the moment, which is somewhat disappointing, but it's a time-consuming exercise. The existing calculations, I think I pointed out to others in the past, is basically 1970s in our main tables there, and they haven't really changed significantly there. So they're on the conservative side for some aspects there. They're particularly, I'd point out motors, another area of something of particular interest you should be looking at too. But we will try to get something done, but we need to really finance or need to really set up the project properly. And that still should be good possibility, given the growth of metering now into the exercise, digital metering, multifunction metering, the ability to access records. Perhaps that'll give us a good opportunity to come back with some more realistic numbers. And obviously the industry promotion of energy efficiency legislation, BCA, through the BCA and the likes.
Well, thank you, Roger. That is the end of our questions, and again we apologise for the delay. It was out of our control. If you have any further questions, feel free to email me or contact NECA. Again, thank you.